Okay, so today I'd like to talk to you about the concept of variance and spread. In order to explain this, let's think about a game that's really popular in Canada. It's a variant of bowling known as 5-pin bowling. If we think of somebody actually playing this game of bowling, we'd like to measure how consistent they're being. So for example, a person who is always knocking down 5 pins would be really consistent. In order to think about this, let's think of a sample space of all the possible ways you could knock down these pins. I'll go ahead and draw a few different ways. And there are so many more, but I'm not going to draw too many of them. Now remember, a random variable takes elements from the sample space and actually maps them directly to a real number. In this case, our real number is going to represent the number of pins that we knock down. Let me show you this. We might like to think of all the different ways where you could score 2 points. As you can see, this partition contains all of those ways. The random variable is in charge of actually taking any one of these elements and mapping it directly to a real number, which in this case is just 2. Call this random variable capital A for Alfred, because we can imagine that the person playing is named Alfred. Therefore, we can say that capital A of this entry is just equal to. Now I'm going to go ahead and get rid of all of these markings that I don't need. Imagine we let Alfred take exactly 10 throws, and we recorded his results on this axis. From these results, you can see that Alfred missed all of the pins 4 times, and he knocked down 1 pin 2 times, and so on. We don't really need the sample space for anything else either anymore, so let's just get rid of that for now as well. Now let's pretend Alfred was playing with 2 of his friends, Betty and Claire, and they got the following results. Now from these results, you can see that Betty always seems to knock down exactly 4 pins, and Claire is really inconsistent. She either gets all of the pins, or she misses all of the pins, and nothing in between. Now we'd like to talk about who you think is most consistent. You already know how to find the average of all of these groups, so let's do that first. If I just go ahead and plug into the formula that we saw last time, we get the following averages. As you can see, the averages tell us pretty much nothing about this. What we really need is to check how far these results are spread from the average. As you can see, Betty has no spread from the average because all of her results are exactly average. Claire, on the other hand, has a lot of spread, and Alfred doesn't have much at all. The trouble here, of course, is to precisely define what we mean by spread. The simplest thing we can say is that if we take all these values and shift them all up, so for example, if Alfred played again on Tuesday and got these results, now as you expect, since all the results have moved up by 2, his average should have also moved up by 2. So now it's at 3.1. But his spread hasn't really changed at all. So we'd like some kind of measure that would allow this and this to return the exact same spread. It turns out that there are a lot of ways to do that, and I'm going to discuss just a few with you. All of our methods are going to center around the idea of seeing how far these values are from the mean. So to show this, let's show how far all the different values that these people scored are from the mean. So as you can see, our mean was just 1.1, and this value is 2, so we jumped forward by 0.9 to get there. To get here, we just went forward by 1.9. And if we look at Claire, we can look at this value and see that we had to jump forward by 2.5. And to get to this value, we had to jump backward by 2.5. So our first impulse, perhaps, is just to add up all of these values, and that can be our spread. That's not such a good idea. I mean, we said that we want Betty to have very little spread, and we want Claire to have a lot of spread. If we just added up 2.5 and negative 2.5, we just end up getting 0, so that's no good at all. So then we really have a whole bunch of different choices that we could use that actually would work. The first is we could just take the absolute values and add. So if we calculate this for Alfred, we can just see that he was 1.9 units away from the mean 1 time, 0.9 units from the mean 3 times, 0.1 from the mean 2 times, and 1.1 from the mean 4 times. Since he took 10 shots, we have to then also divide this by 10 to make it an average. So we can see that his absolute value spread is just 0.92. If we do this for Betty, we can see that she was just 0 units away from the mean exactly 10 times, so her spread is just 0. And for Claire, we can see that she was 2.5 units from the mean 5 times here, and 2.5 from the mean 5 times here. So she's been 2.5 units away from the mean 10 times, and then we divide by 10, so we can see we just get 2.5 again. Now as you can see, Betty gets the lowest spread, followed by Alfred, then followed by Claire, just as we wanted. Alternatively, we can just look for the maximum distance, which is another simple way. We can see for Alfred that his maximum distance from the mean was just 1.9. Betty was always exactly on the mean, so her maximum distance is 0. And Claire's maximum distance is just 2.5 units away from the mean. And again, we get the same order. Betty has the lowest spread, followed by Alfred, followed by Claire. Now, it's not hard for you to imagine places where the maximum distance would make more sense and places where the absolute value would make more sense. However, in general, the most useful measure of spread is neither of these two. The most useful way to measure spread is actually this concept of variance. Variance isn't actually that hard to calculate. All you have to do is just take these distances and then square them. Squaring them is going to get rid of any negative signs, so you don't get the problem that we had before, and then you just take the average of all the squared values. Let me go ahead and do that for all the values on the page right now. For Alfred, we can see that we were 3.61 squared units away one time, we were 0.81 units away 3 times, we were 0.01 squared units away 2 times, and we were 1.21 units away 4 times. Dividing this by 10 will give us our average, which in this case is just 1.09. Now for Betty, squaring 0 is still 0, so her variance is just 0. And for Claire, she was 6.25 squared units away 10 times. So let's go ahead and work that one out too. We should then also divide by 10 to actually find the average. The difference here, however, is that Claire's value is so much higher than Alfred's and Betty's. Therefore, the variance places a much larger weighting on values that are further away from the mean. It turns out as well that the variance is much better behaved mathematically than the other two measures of spread, which is why we're going to spend a lot more time focusing on it than the others. I'm going to remove Betty and Claire for now and focus on Alfred to help us understand this concept of variance a little bit better. So we define the variance as the average squared distance to the mean. After the other two left, Alfred decided that he wanted to spend a bit of time improving his game, so he bowled 1,000 more times, and here are his results. Somehow, that afternoon, he didn't manage to ever knock down 4 or 5 pins. We're going to define his squared variance with the symbol s squared. Now it's also possible that the mean has changed, so let's get rid of the current one for now. The first step of finding the variance is to actually find the sample mean, so let's go ahead and do that for these particular values right now. If we do this, we see that the value is 1.104. We can say that our distance to 0 is just 1.104 units squared, so let me write that down first. And we can see that that happened 388 times, so we can go ahead and add that to the sum. Now the distance to 1 is just 0.104, and that happened 213 times. Then we can repeat this for 2 and 3, or we can leave these guys off since they're just 0 anyway. And we should also divide by the 1,000 bowls he took. If you did actually put this into a calculator, you'd find that his squared spread value is just 1.055. So let's pretend that I go ahead and replace these frequencies for the actual probabilities that Alfred knocks down each number of pins. Now again, we're going to come up with the variance formula by analogy. Let's start with this formula and make it look a little bit more like probabilities. The first thing I'm going to do is I'm going to replace these 1.104s for the sample means to just cut down the amount of writing we have to do. Now we can also go ahead and break up these fractions to write things in a more familiar way. Now as you can see, this guy is kind of like what we would get if we put 0 into the PMF. So we can write this. And this is what we would get if we put in 1. So therefore we go ahead and define our variance that can work with probabilities instead. Just a few notes about this equation. When we're dealing with the actual variance, we don't use s squared, instead we use sigma squared. Instead of using the sample mean, we use the population mean, and we replace all fractions for actual probabilities. But other than that, these two equations are pretty much the same. As you can see, however, we again need to find the actual mean before we can actually calculate the variance. I'll go ahead and do that very quickly. Putting this all into a calculator, we get exactly 1.1. And then we can just sub into this formula to actually find the actual value. When I actually put this into a calculator, I got 1.05. Now as you can see, this is a pretty tedious calculation, and there are actually functions in your calculator to help you do this a lot faster, so I definitely recommend you look into them and figure out how to use them. Now as one final thing, I'm going to go ahead and get rid of all this maths and write this in the most general form. So, in summary, to actually calculate the variance, the first step is to actually find the mean or average. The second step is to find all the squared distances to the mean. And then the final step is to just take their average. We can summarize this in the following formula. I know it looks scary, but let's talk through it. To actually calculate the variance, take every x that comes out of your random variable, find its squared distance to the mean, multiply by its probability, and then just add them all up. Now there's only one final thing to say. Because this variance is determined completely by the random variable, we have another notation that makes this a little bit more explicit. Now these are just two alternative notations for the exact same thing, so no matter which one you see, don't get confused, they're exactly the same. Now you may be wondering why there's been a square on this thing the whole time. Yes, it is partially because we've been squaring, but there is actually a deeper reason, and we'll go through that in a future lesson.